Okay, let's start at the very beginning, designing the pipeline itself. This is really the foundation of everything. We're talking about creating that automated, reliable path that takes code from a developer's keyboard all the way to a production-ready, verified artifact.
Now, what the exam is really testing here is your ability to architect a complete end-to-end flow. You need to show you can take raw source code and turn it into something that is secure, totally unchangeable or immutable, and completely traceable. Think of it like a high-tech digital assembly line for your software. So what does this ideal assembly line look like? Well, it all kicks off the second a developer commits their code. That automatically triggers a build. Now, the key tool to know here is Kaneko. It's a real game changer because it builds your container image securely inside another container, which means it doesn't need risky privileged root access on the build machine like the old Docker and Docker method did. It's way more secure. Then, once the build is done, it's automatically scanned for any known vulnerabilities, and only if it passes that scan does it get stored as a final permanent image in Artifact Registry. These 4 principles are pretty much guaranteed to be on the exam. First, tagging. You absolutely have to tag your images with the git commit SHA. Why? Because it gives you perfect traceability. You can look at any container running in production and trace it back to the exact line of code that created it. We've talked about secure builds with Kaneko and automated scanning. And finally, always use Artifact Registry. It's your central, single source of truth for all your artifacts.
You'll almost certainly get a question that tries to trip you up between Artifact Registry and the older Container Registry. Just remember this, the answer is always Artifact Registry. It is the modern successor and it's better in literally every way. It gives you regional storage for lower latency. It has much more fine-grained IAM controls right down to the repo level. And look at this, it supports a ton of different formats, not just Docker. It is the hands-down winner for any new pipeline.
Okay, so you've built your secure, traceable artifact. Awesome. Now, how do you actually get it into production without, setting everything on fire? That is where safe deployment strategies come into play.
The core concept you need to understand here is progressive delivery. The whole idea is that you don't just push a new version out to 100% of your users all at once and hope for the best. No way. Instead, you use clever strategies like canary deployments or blue/green releases to roll out the change gradually, watch it like a hawk, and make sure that if something does go wrong, the blast radius is tiny.
A canary deployment is the classic example of this. You send just a small slice of your live traffic, maybe 10% to the new version of your app. Meanwhile, the other 90% of your users stay on the old stable version. What's great is that services like Google CloudRun make this incredibly easy to do. You can test your new code with real users in a very controlled, safe way. So for the exam, you'll want to remember these key tools in Google Cloud. CloudRun is your go-to for simple, fast canary deployments. But for more complex releases that need to go through multiple stages, like dev, then staging, then prod, Cloud Deploy is your best friend. It even lets you put in manual approval gates. And here's the best part. If anything looks fishy, both tools let you roll back instantly. You just redirect all the traffic back to the stable version in seconds.
All right, let's shift gears and talk about something that I can almost guarantee will be on your exam: managing secrets. We're talking about API keys, database passwords, all that sensitive stuff. How do you handle it securely?
If you only remember one thing from this entire explainer, please let it be this. You never, ever, ever store secrets in plain text. Not in your source code, not in a config file, and definitely not baked into a container image. Seriously, this is the cardinal sin of security, and the exam will test you on it.
And here's a perfect visual of doing it wrong versus doing it right. On the left, you see the insecure method. The password is just sitting there in plain text for anyone to see. The secure method on the right is totally different. Instead of the password, you have a reference to a secret stored in Google Cloud's Secret Manager. The actual plain text secret is only injected into the container at the very last second when it starts up.
So here's your 4-step playbook for secrets. 1. Centralize everything in Secret Manager. Make it your single source of truth. 2. Inject secrets at runtime so they never live on disk where they could be compromised. 3. Use the principle of least privilege. Your Cloud Build service account should only have permission to access the exact secrets it needs and nothing more. And 4. Automate your credential rotation to minimize the risk of a stolen key.
Okay, on to our 4th and final pillar, auditing. Look, it's not enough to just have a secure pipeline. You have to be able to prove what happened, when it happened, and who did it. This is absolutely non-negotiable for security investigations and for any kind of regulatory compliance. This quote right here,
This is a DevOps engineer's nightmare scenario. Imagine a rogue admin deploying something directly to production, completely bypassing all of your security checks, all of your tests, all of your approvals. Without a solid audit trail, you would be flying blind. Auditing is what lets you detect and respond to exactly these kinds of threats.
The great thing is, Google Cloud gives you a ton of tools for this. You've got Cloud Audit Logs, which capture every single API call, the who, what, and when. Your immutable artifacts provide that undeniable link between a deployment and a build. And there's something called SLSEA provenance from Cloud Build, which is basically a cryptographically signed birth certificate for your artifact, proving how it was made. And if you're using Terraform, even your state history in GCS becomes another valuable audit log.
Phew, okay, we have covered a ton of ground. So let's take a second to boil it all down into the absolute key takeaways you need to have locked in your brain for exam day. Here it is, your mental checklist for Section 2. For design, think immutable, traceable artifacts stored in Artifact Registry. For implement, think progressive delivery, canaries, and stage rollouts with Cloud Deploy. For manage, think never, ever hardcode secrets. Inject them at runtime from Secret Manager. And finally, for audit, think Cloud Audit Logs and SLSA provenance for a complete verifiable trail. So I want to leave you with this final question. And this isn't just for the exam, this is for your real-world work. The goal of modern DevOps isn't just to automate stuff. It's about building systems that are fundamentally secure, reliable, and auditable from end to end. Nail that, and you won't just pass the exam, you'll be a fantastic DevOps engineer. Good luck with your studies.